Okay, today we're going to talk about rectangles, rhombi, and squares. Now, I want to go back to this beginning picture right here on slide 19. Now, remember, a quadrilateral is a four-sided polygon, and in the last lesson, we talked about what a parallelogram is. Well, today we're really still talking about parallelograms. We're just talking about a more specialized shape, such as the rectangle and the rhombus, and then an even more unique shape which would be the square. So we're still talking about parallelograms. We're still talking about quadrilaterals. We're just talking about them in a more specific way today. So go to slide 23. That's where we're going to start. So the learning target is I can apply properties of rectangles, rhombi, and squares. So here is a rectangle. Most of you are familiar with a rectangle. Now, the first five properties are the exact same as what we went over in the last lesson with parallelograms. So opposite sides are congruent. So the opposite sides here are going to be the same. Opposite sides are parallel. So they have to be, the sides, opposite sides can never intersect. Opposite angles, and they're usually connected by these diagonals. Opposite angles are congruent. Consecutive angles are supplementary. So these consecutive angles, where they share a common side, add up to be 180. And then the last one, diagonals, bisect each other. So those are the same properties as a parallelogram, but a rectangle has two more properties added to it. So here is what makes it a rectangle and not just a parallelogram. So the first one is there are four right angles. So at each vertex, okay, where this angle is created, these are 90 degrees. Each of them are right angles. 90 degrees. And the diagonals are congruent. So not only do they bisect each other and cut each other in half, but they're also the entire thing, both of them are the same measure. So if this diagonal is 5, then this other diagonal has to be 5. Okay. So we're going to do a couple of examples here. Now, I didn't bring my Elmo. I'm doing this at home, so I didn't bring my Elmo, so it's going to look a little bit different. So if you need to pause the video at any time, then do that and then write things down as we go. So example 1 says quad RSTU is a rectangle with diagonals that intersect at P. Okay, so I'm going to go to a different slide. I'm going to start this. Okay. So I have triangle RSTU with diagonals that intersect at P. Okay. Now reading the rest of this example, I see that RSU is 3x minus 5. And then UST is 4x plus 4. So that takes care of RSU. This angle right here is 3x minus 5. UST is 4x plus 4. Now, I know that this entire corner is equal to 90 degrees. So the half the battle, and really a majority of the battle here, is setting up the problem. Okay, if you get the problem set up, most of the time we're going to get the rest of it correct. So 3x minus 5 plus 4x plus 4 equals 90 degrees. Okay. So then I'm going to solve this. I'm going to combine like terms. 3x plus 4x is 7x. Negative 5 plus 4 is negative 1 equals 90. Add 1 to both sides, so 7x equals 91. Divide by 7, x equals 13. So again, I apologize for not working this all the way through. I had to do it a little bit different at home, and this was the best I could come up with without that document camera. Okay. So pause it, finish up that particular slide, and be sure and insert it back into the example here. But we're just following exactly what we have. We were working up in this corner, and we know that each corner is a right angle in a rectangle. All right, let's look at example 2. Quad ABCD is a rectangle with diagonals that intersect at point P. AC equals 4x minus 13 and DP equals x minus 7. Find the value of x. So we're going to first draw the rectangle. Just draw a regular rectangle, ABCD, and then you have diagonals that intersect at P. AC is 4x minus 13, and DP is x plus 7. Now, when we were talking about parallelograms, the fifth property says that diagonals bisect each other. So these diagonals cut each other exactly in half. So if this part is x plus 7, and this is cut exactly in half, then the other part has to also be x plus 7. And what do we know about diagonals of rectangles? Well, they're the same. So you set it up like this. So see how if this is x plus 7, this is x plus 7. So 4x minus 13 is the same or congruent as x plus 7 plus x plus 7. Okay. So take a minute and solve this. Combine like terms on the right-hand side. You have x plus 7 plus x plus 7. So you have 2 x's. And then 7 plus 7 is 14. So just working my way through, I end up with 4x minus 13 equals 2x plus 14. Well, since I have a variable on both sides of the equation, I want to move the smallest one. So 2x is smaller than 4x. So I'm going to subtract 2x from both sides so that I get the variables combined together. So 4x minus 2x is 2x, and then this cancels out. So then it just becomes a two-step equation. 2x minus 13 equals 14. Add 13 to both sides. 2x equals 27. Divide by 2. And there's 3 ways to write your answer. You can leave it as 27 over 2. You can make it a mixed fraction, 13 and a half, or you can make it into a decimal, 13.5. It's a multiple choice question. You might see any one of those answers, so any one of them were acceptable here. But just follow the properties, knowing that the diagonals bisect each other and that the diagonals of a rectangle are the same. So again, be sure and take a picture of this. Oops, let me undo there. And insert them in your notes. Okay. All right. Let's talk about a rhombus. Now, a rhombus is a shape that we don't use that often, but it's still very important. So the first couple of things are the first 5 properties. Because a rhombus is a parallelogram, it shares the first 5 properties the same way a rectangle does. So opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, Consecutive angles are supplementary, and diagonals bisect each other. So pause the video a second and type in those things. Now, there are three more properties. Okay. Now, the first two look kind of like what we saw in a rectangle, but there are some different parts to that. So instead of being four right angles, notice the rhombus is kind of shifted to one side. In a rhombus, we have four congruent sides. So all four sides, not only are the opposite sides the same, but all four sides are exactly the same. And then the diagonals are perpendicular. Okay, so when you cross them, it forms a 90-degree angle at all four angles. Okay, so this is 90 degrees, this is 90 degrees, and so are the other two. All of these equal 90. They're perpendicular. And then the last one, the diagonals bisect opposite angles. So this angle, this diagonal's coming in, it cuts this entire angle in half. And remember, each one has to be exactly the same. That's what bisect means. So not only do they bisect each other, where the length of these lines are the same, but it also bisects these angles to where they're half of what they used to be. Okay. Now, unfortunately, on example 1, there's a mistake there. So I went to do that example and I couldn't figure out where I made the mistake. So we're going to skip example 1 on this. And we're going to go to example 2. It says quad ABCD is a rhombus with diagonals that intersect at point W. So if the measure of angle AWB equals 2x plus 8, find x. So there's a whole lot of words there. I have to draw a picture to be able to know what I'm looking for. So let's look at this. So I have ABCD is a rhombus with diagonals that intersect at W. Angle AWB is 2x plus 8. Now, if I look at my properties, particularly the ones for a rhombus, it said the diagonals are perpendicular, which means they create 90-degree angles. So I know this AWB angle is 90 degrees. So I'm going to set it up to where 2x plus 8 equals 90 to be able to solve for x. Okay. So it's a two-step equation. I'm going to subtract 8 from both sides. 2x equals 82. Divide by 2. X equals 41. So again, as long as you set up the problem correctly, knowing that those diagonals are perpendicular, you can easily solve a two-step equation. So go ahead and insert that into example 2. Again, sorry, apology, example 1. I just couldn't figure out. RSW, I didn't know something. I missed something about the diagonals, I'm sure. All right. So rectangles and rhombus are on the same line of a perpendicular. The last one is the square. Now, a square is a mixture of all of them. So we've written all this down already. So in the left-hand box there, those are the properties of a parallelogram. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. So pause the video and fill those in, but those are the same properties that we wrote down for parallelograms. Now, on the right hand, this top box, these are the properties specifically from a rectangle. There are 4 right angles in a square, and the diagonals are the same. So each corner is a 90-degree angle, and both diagonals are the same. And then this last box is shared with the rhombus. So there are 4 congruent sides. The diagonals are perpendicular, so these angles in the middle are also 90 degrees. So you got 90-degree angles all the way around. And then the diagonals bisect each other. So not only are these corners 90 degrees, but ABO, okay, this part right here is cut in half. So this would be 45, this would be 45. And you'd have those in other places since these angles are bisected by the diagonal. So let's look at example 1. Quad RSTU is a square with diagonals that intersect at point O. If the measure of ROS equals 5x plus 5, find x. So let's look at this example. Let's draw the picture correctly. So RSTU is a square with diagonals that intersect at O. The measure of the angle ROS is 5x plus 5. So what do we know about diagonals, the angles of the diagonals? We know that they're perpendicular. Anytime we hear the word perpendicular, we're thinking 90 degrees. So 5x plus 5 equals 90. We know that these middle angles are 90 degrees because it shares the same properties as a rhombus. So this is a 2-step equation. Go ahead and solve this. Subtract 5 from both sides. 5x equals 85. Divide by 5. X equals 17. So again, if you set up the problem correctly, the rest is really easy because you're solving that 2-step equation. So again, pause the video and insert the image here. And then let's look at the last example. Quad MATH is a square with diagonals that intersect at point O. If the measure of AMT equals 5x, find x. So let's draw a picture one last time. So MATH is a square with diagonals that intersect at O. It says if the angle AMT is 5x, find x. So what do we know about the corners of a square? We know that they're right angles, that they're 90 degrees. We also know that the diagonals bisect or cut these angles in half. So what's half of 90? So if you said 45, that's correct. So this angle right here is 45 degrees. So to solve for x, we say 5x equals 45. And then this is the easiest one. We divide by 5 on both sides. X equals 9. So these are the notes. You can go back and listen to these again. You can pause it at any point you need. You can go back and read them, or you can ask questions. If you need any assistance, be sure and let us know. Sign up for the win sessions. Do what you need to do to be sure you get the homework done. But we'll be working on the assignment for the remainder of the period, and just let us know if you have any questions.